Which set for electron affinity is correct? Which one of the following sets for electron affinity is correct? Let us see the matter. Which one of the following sets for electron affinity is correct? First of all, let us see what is electron affinity, and it depends on size of atoms. Electron affinity, and it depends on the size of atoms. What is electron affinity? Let us consider this is nucleus of an atom and this is valence shell or outermost shell. Here there is an electron. Electron is negative in charge, nucleus is positive in charge. So there is attraction between these two species. Due to this attraction, when this electron falls on the valence shell of this atom, then it releases some amount of energy, which is called electron affinity, abbreviated by EEA. For example, suppose this is an atom, fluorine. When it receives electron, then it changes to uninegative ion, and at that time it releases some amount of energy. This energy is called electron affinity. Definition is the amount of energy released when 1 mole gaseous atoms receive 1 mole electrons and change to 1 mole uninegative gaseous ions, then the energy released is called electron affinity. It is abbreviated by EEA. Now let us see how it depends on the size of the atom. This is the atom and it is in size. Let us consider another atom which is a bit bigger in size. Here electron. Electron is negative in charge, nucleus is positive in charge. Here this is the distance, but here distance is greater. Attraction depends on the distance. Less distance, higher attraction. Bigger distance, less attraction. That is, attraction depends on the size of the atoms. Attraction increases when size of the atom decreases. Then change of electron affinity should be like this: fluorine, chlorine, bromine, iodine, astatine, tennessine. These two are considered out of consideration because these two are radioactive elements. This is smaller in size, chlorine is a bit bigger in size, bromine more bigger, iodine bigger in size. So electron affinity should be higher for fluorine, then chlorine, then bromine, and then iodine. So as electron affinity depends on the size of the atoms, then the series should be like this: fluorine, chlorine, bromine, and iodine. That is, this one should be the answer, but not this one. This is the answer. Firstly chlorine, then fluorine, then bromine, then iodine. Now let us see what is the reason behind this. Electron affinity for chlorine is greater, then fluorine, then bromine, and then iodine. Why? This is now we are going to learn. We know that fluorine is smaller in size, then chlorine a bit bigger in size, bromine more bigger, and iodine more bigger in size. That is, here all the atoms carry 7 electrons in its outermost shell. Here 7 electrons, 1, 7 electrons, 7 electrons in the outermost shell. Here 7 electrons, 7 electrons in the outermost shell, 7 electrons. Here 7 electrons. Halogen, suppose fluorine, 9, 1s2, 2s2, 2p5. Outermost shell contains 7 electrons. Similarly, chlorine, 3s2, Tp5, bromine, 4s2, 4p5, iodine, 5s2, 5p5. That is, all the halogens contain 7 electrons in their outermost shells. Now we see that in case of fluorine, concentration of electrons in the outermost shell is very high because this is smaller in size, and here concentration is very less, and then here less. In case of fluorine, concentration of electrons in the outermost shell is very high, and for this reason addition of another electron becomes tough. And that is why energy released here is less energy. Due to the higher concentration of electrons in its outermost shell, it feels less attraction to the additional electron. Now let us see what is the amount exactly they releases. Fluorine receive 1 electron to form uni-negative ion, and at the time it releases 328 kilojoule per mole. Then chlorine uni-negative ion, it releases 349 kilojoule per mole. Then bromine, it releases 325 kilojoule per mole. Then iodine, it releases 295 kilojoule per mole. That is, firstly chlorine, its electron affinity is higher, and then fluorine, after that bromine, and finally iodine. Electron affinity of the halogens, which set for electron affinity is correct? This is the set. Firstly chlorine, then fluorine, then bromine, and then iodine. Due to the size of the atoms and concentration of electrons in their outermost shells. Thank you for watching.